Welcome back. Today we're going to look at solving right triangles. This is something you might do in a geometry class, trigonometry. I've actually had occasions in my woodworking to need to use the skill of solving right triangles. And I know my title says solving right angles. We're going to solve right triangles. Remember that a triangle has 6 parts. Okay, we tend to think of 3 angles, but there are also 3 sides. So there's a total of 6 parts. What it means to solve a triangle is that you determine the measurements of all of the unknown parts. So the thing is that in order to completely solve a triangle, you need to be given at least 3 parts. If you're not given 3 parts of the triangle, you can't solve the triangle. In fact, at least one of the parts that you're given that you start with must be one of the sides. Okay, so we have a few different scenarios here in these examples that I want to look at. Okay, so let's look at in triangle ABC. Now, when I label triangle ABC, I'm going to consistently label angle C as my right angle. Okay, so in this case, we're told that angle A is 20 degrees. We're told that angle C is 90 degrees and side C is 15. Now, when we're given the parts of a triangle, what we do is we have angle A, and then the side opposite angle A is side A. We've got angle B, the side opposite angle B is side B, and the side opposite angle C is side C. Please notice that I labeled the angles with a capital letter and the sides with a lowercase, and that is what we do in trigonometry. So if I want to solve the triangle, what I'm going to need to do is find the remaining 3 parts. In other words, I need to find the measure of angle B. I need to find the length of side A. And I need to find the length of side C. Okay. To find the measure of angle B is not too difficult because if you recall, the 3 angles of a triangle add up to 180 degrees. And this symbol here is trying to be an angle. So angle A plus angle B plus angle C is 180. If angle A is 20 degrees, we don't know angle B, but angle C is 90 degrees. Notice that these 2 angles add up to 110. That means the remaining value for angle B would be 70 degrees. That's fairly simple. In a previous video, we talked about the trig ratios. If you've not watched that, go watch on my channel, watch the trigonometric ratios. And what you'll find there is we're going to look at the ratios that can be used to solve the triangle. So if you recall, the sine of angle A is opposite over hypotenuse. Cosine would be adjacent over hypotenuse, and tangent is opposite over adjacent. Now, one thing I neglected to write in my picture here is that side C is 15. So there's my hypotenuse. If I use angle A, I could say that the sine of angle A, which is 20 degrees, is going to equal the side opposite, that would be A, divided by the hypotenuse of 15. And so A will equal 15 times the sine of 20. Okay, now I've gone and gotten my calculator here. And so to do 15 times the sine of 20, get this out of the way. To do 15 times the sine of 20 with my calculator, 15 times, before we do that, here's something I need to talk to you about. You're going to press mode on your calculator, and you notice here it says, let me cursor down, see it says radian and degree. We're going to do degree mode for right now. Everything's measured in degrees, so you want to make sure your calculator is set in degree mode. Now 15 times the sine of 20 degrees. Press enter, and we know that A is equal to approximately 5.13. Depending on the course you're in, who your teacher, professor, instructor is, they might say to go different measurements. I like to measure sides to 2 decimal places, so I'm going to call that 5.13. Now to find B, Yeah, it's not B. C we need to find. It's B that we need to find. So to find B, I think what I'm going to do is look again at my 20 degrees, but B is the adjacent leg. C is still the hypotenuse. So the cosine of 20 degrees is the adjacent leg B divided by the hypotenuse of 15. So B is equal to 15 times the cosine of 20 degrees. Okay. Now there's a couple of options here with the calculator I'll show you. First of all, I could just do 15 times the cosine of 20 degrees and get my B value of 14.10 if we go to 2 decimal places. The other thing I could have done is if you cursor back up, you can highlight a certain command. If I would have highlighted back up to the 15 sine 20, hit enter, the calculator will pull that entry back down. I could now back up to the sine and simply change that to cosine and get my 14.095. Okay, so there's a little bit of work with the calculator as well. Let's look at a couple more examples. Okay, I've tried to come up with different examples where I'm given slightly different scenarios. Okay, so in the first example, notice I was given an angle. In addition to the right angle, I'm given an angle and the hypotenuse. So in example 2, we have triangle ABC again, where C is the right angle. So we've got A, B, C. We're told that angle B is 40 degrees, angle C is 90 degrees, and B is 12. So we want to solve for side A, side C, and angle A. So we need to find angle A, and side C. Angle A is easy again because, again, 90 degrees plus 40 degrees is 130. If I subtract 130 from 180, that would be 50 degrees. So the angle is easy to find if I'm given one of the other angles. Okay. Now, to find side A, notice that if I use my 40-degree angle, 12 is, I'm going to have to use that. That's the opposite, and A is the adjacent. So opposite over adjacent is tangent. The tangent of 40 degrees is equal to 12 divided by A. If I multiply both sides by A, and then I divide both sides by the tangent of 40, you'll notice that A equals 12 times the tangent of 40. The other thing you can notice is that the tangent of 40 and the A just changed places. Okay, so you can use that little trick as well. So now I go to my calculator, 12 divided by the tangent of 40. Notice I've not checked that mode. As long as you leave, once you put your calculator in degree mode, it won't change unless you or someone else changes it on you. So A is 14.30. To find side C, I'm going to have some options. I think with the 40 degrees, I'm going to use sine because 12 is the opposite leg. C is the hypotenuse. And remember that sine is the ratio of the opposite divided by the hypotenuse. I'm going to use the trick where the sine and C will change places. So C is 12 divided by the sine of 40 degrees. To go to my calculator, I'm going to do what I showed you before. I'm going to come up here and grab that entry because instead of doing 12 divided by the tangent of 40, we want to do 12 divided by the sine of 40. And I simply changed the tangent to sine. And so C is 18.67. Okay, so there's that triangle solved. The things I want to make sure about, by the way, is that notice that 40 degrees is the smallest angle. My angles are 40 degrees, 50 degrees, and 90 degrees. 40 degrees is the smallest angle. 12 is the shortest side. That should line up. C is 90 degrees. That's the largest angle. So side C should be the longest side, and that does match up as well. Okay. Number 3. In triangle ABC, so again, we have triangle. I don't like that triangle. Give me a moment while I redraw that one. Just want to give myself a little bit more room. So here's A, B, C. Angle B is 55 degrees. C is 90 degrees. And A is 10. This is very similar to number 2 that we just did, except instead of giving you the side opposite angle B, I gave you the side adjacent to angle B. But it's going to work pretty much the same. Solve the triangle. We're going to need to find angle A, side B, and side C. I like to set mine up like this to remind me of 2 reasons. One, to remind me of what the 3 parts I need to find are, but also then when somebody's reading my work, if you're a student taking a test, somebody's reading your work, it makes it very easy for that grader to find your solutions, to find your answers. Okay, so again, the 3 angles of the triangle, I'm going to use my calculator this time, add up to 180. I'm going to subtract 90 for angle C. So every time we start at 90, subtract 55 from that, and angle A is 35 degrees. So angle A is 35 degrees. I could write it on there. Now you notice, just like in example 2, we don't know the hypotenuse, so I can't use sine or cosine initially. So I'm going to use tangent. The tangent of 55 is B over 10. So that's B over 10, opposite over adjacent. So B is equal to 10 times the tangent of 55 degrees. So 10 times the tangent of 55 degrees. Also notice I don't always close the parenthesis on the calculator. That's not necessary either. So side B is 14.28. To find C, now I am going to use a sine or cosine. I'm going to use the cosine of 55 degrees is equal to 10 over C. I just don't like having the unknown value in the denominator as much as possible. Sometimes you can avoid it, other times you cannot. Here's a time where you cannot. So C is equal to 10 divided by the cosine of 55 degrees. And again, remember I multiplied both sides by C, divided both sides by the cosine of 55. And now we have 10 divided by the cosine of 55 degrees. So C, it should be the longest side. Again, we can check that. 17.43 is the length of side C. Okay. Now, in examples 1, 2, and 3, I gave you examples where of the 3 parts that we were given, 2 of them were angles, and then 1 was a side. In example 4 and example 5, I probably should have made more space so you couldn't see example 5 yet, but in 4 and 5, what you'll notice is we have angle A, B, and C. We know that angle C is a 90-degree angle. We also know that side B is 15 and side C is 20. We don't know the measure of angle A. We don't know the measure of angle B, and we don't know side A. Okay. So let me put it back to green just for consistency. So we're going to need to solve for angle A, angle B, and side A. So there's a little bit more involved here when I have to solve for one of the angles. It's nice when one of the things I have to solve for is an angle because I just do the 180 minus 90 minus whatever the other angle is. In this case, there's a couple of ways I could start. Okay, I could start by finding side A using the Pythagorean theorem. So A squared plus 15 squared is 20 squared. A squared plus 225 equals 400. So A squared is 175, and A is the square root of 175, which I could either call that 5 root 7 or the square root of 175 is 13.23, depending on if we want the exact value or the decimal approximation. So that's one way that I could find A. Okay. It's probably the way I would recommend finding A. The next thing I would do is decide if I want to find angle A or angle B first. If I want to find angle A, notice that I have the adjacent leg and the hypotenuse. So I would say that the sine of angle A is adjacent over hypotenuse. If I want to use angle B, oops, I'm sorry, that's wrong. That's not sine. That would be cosine of A. Glad you caught me. Cosine of A is adjacent over hypotenuse. If I wanted to use angle B, where 15 now, this is what I was thinking, would be the opposite. So the sine, I could do the sine of angle B is 15 over 20. And I would do either one of those the same way. The thing that I'm going to do here is that since the cosine of A equals the cosine of 15 over 20, essentially what I'm going to do is take the inverse cosine of both sides. And I apologize, I'm out of control here. So cosine of A equaled 15 over 20. I'm taking the inverse cosine of both sides. Now the inverse cosine of the cosine of A is just simply equal to A. So A is equal to the inverse cosine of 15 over 20. If you need this, back me up, watch it a couple times, see if it starts to sink and make sense. I'll do it a few more times. Now you'll notice on the calculator here, you've got the sine button, but right above it in blue says inverse sine. The cosine button right above it in blue says inverse cosine. The tangent button right above it in blue says inverse tangent. So I want to do the inverse cosine of 15 over 20. And what this is going to do is tell me what angle has that trig ratio. So I know that angle A is 41.4 degrees. Okay. If I would have done the same thing using the sine of B equals 15 over 20, I would say that B is the inverse sine of 15 over 20. So the inverse sine of 15 over 20 would be 48.6 degrees. And actually, that's how I would solve that triangle. Okay. I would use cosine A is 15 over 20 and sine B is 15 over 20. And if you wanted to check it out, you do know that angle A plus angle B has to equal 90 degrees, and you can verify that there you are. Okay. So this here can get a little bit messy with the inverse sine and inverse cosine. Let's look at one more example. And let me push that up. Didn't give myself a lot of room. So here's triangle ABC. One last example. A, B, C. Again, angle C is 90 degrees. Side A is 20. Side B is 12. Okay. Now, in the previous example, I gave you a leg and a hypotenuse. In this example, it's similar, except we have two legs. We don't know the hypotenuse. The three pieces we need to find are angle A, angle B, and side C. I think I'm going to find side C first. And again, let's just use the Pythagorean theorem. 12 squared plus 20 squared is equal to C squared. 12 squared is 144. 20 squared is 400. So c squared is equal to 544. That means that c is equal to the square root of 544, or 23.32. Okay. I think I mentioned earlier that I like to measure my sides to 2 decimal places. I measure my angles to 1 decimal place, which is the rule that I tend to go by. Now, I can find angle A, angle B, either way. For angle A, notice that we have the leg opposite and the leg adjacent. So the tangent of A is equal to the leg opposite divided by the adjacent. In fact, if I consider angle B, 12 is the opposite leg and 20 is the adjacent leg. So I could say that the tangent of angle B is 12 over 20, and I'm going to solve those two. Since I've already got this color on my marker, remember inverse tangent. B is the inverse tangent of 12 over 20. So inverse tangent 12 over 20 is 30.96 degrees. So B is 30.96 degrees. Now, don't get too carried away here with what I'm about to show you, because you might be thinking something different. But now to find A is the inverse tangent of 20 over 12. So it's the same thing. Inverse tangent of 20 over 12, and I should get 59.04 degrees. 59.04, whoops. 59.04 degrees. Now, in case you're wondering and you're asking, do I really have to do both of these calculations to get angle A and angle B? And really you don't, right? So let's pretend that I hadn't done that command and I only did the inverse tangent of 12 over 20 to find angle B. Remember the relationship between A and B. They add up to 90 degrees. So I could have just done 90 minus angle B and gotten angle A. Okay, so any one of those ways will work. So I hope that this is a good rudimentary look into solving right triangles with a lot of different variations. Remember that when you're solving right triangles, the key is you're given 3 parts of a triangle. Your goal is to solve and find the measurements of the other 3 parts. And just remember your trig ratios, take your time and go through it slowly. I hope that this is helpful. Please be sure to like and subscribe if you found this helpful. Thank you.